Okay, 2019 Mechanics AS, question 1. We've got a parachutist. So a parachutist falls vertically from rest from a helicopter which is hovering 550 metres above horizontal ground. Parachutist models particle falls for 3 seconds before her parachute opens. Question A says, find the speed of a parachutist the instant her parachute opens. So she starts from rest, so U equals 0. Okay, acceleration due to gravity is being modelled as 10 metres per second squared. So we get A equals 10. I'm taking down to be positive because all motion is positive in this point. Okay, so A is 10. Okay, we've got 3 seconds, so T equals 3. And we need to work out the final speed after 3 seconds. So we need to work out V. So we're using V equals U plus AT. Okay, U is 0 and 10 times 3 is 30. So 30 metres per second. Alright. B. Sketch a speed time graph for the motion of a parachutist from 0 to T. So we get that she starts off at 0 metres per second and goes up to 30 metres per second. So that's V metres per second. Time in seconds. Okay, and at 3 seconds she's travelling at 30 metres per second. Okay. She then opens a parachute and decelerates 12 metres per second squared for 2 seconds. So that'll slow us down by 24 metres per second, taking her down to 6 metres per second at 5 seconds. And then she carries on at uniform speed until she hits the ground at time T. Okay, so there's our graph. Okay. Part C, find the nearest whole number for the value of T. Hopefully you did this without making the same numerical mistakes I did. Okay, so C, easiest way is area under the graph is equal to 550, the distance she travels. Okay, so we've got a triangle. So the area of a triangle, 3 times 30 divided by 2. Plus, we've got a trapezium. Area of a trapezium, 30 plus 6. A plus B divided by 2 times by the height, which goes from 3 to 5, so that's 2. Plus by the area of that rectangle. So it's 6 high and it's T minus 5 long. And that's equal to 550. There are other ways of working it out, but that's the one I went with. So 3 times 30 over 2 is 45. 36 divided by 2 times 2 is 36. 6 times t is 6t. 6 times 5 is 30. Equals 550. Okay, so when we rearrange that, I look at what I've done, because I did make mistakes. Okay, we get 6t equals 499. So we get t equals 83.16 recurring. And it says to the nearest second, so that's 83 seconds. Okay. Right. Part D says that we're now taking air resistance into account. Okay. So basically she'll start off with the acceleration of 10 metres per second squared. But then as air resistance gets bigger, as she goes faster, okay, we'll get more of a slowing down and less of a gradient to there before she opens a parachute. Okay, so this bit will be lower, her top speed will be lower. Okay, so the top speed is lower, then the area under graph is going to be lower. Okay, so this bit will have to be longer in order for it to reach the ground after 500 metres. So part C, T would be higher or longer. Okay, as maximum speed would be lower. Okay, part E, alright, says what else could we take into account as well as air resistance? Okay, so you can't refer to anything that would refer to the air resistance thing. Okay, I went with, okay, that was D, sorry. non-uniform deceleration when parachute opens. Okay, I thought that was the most obvious one. You could put in other things like effective wind, okay, the fact that it's unlikely to be a one-dimensional model because of wind, things like that. But I went with that one because it was the most obvious to me. Okay, hope that all makes sense. Stay safe.